if n is a multiple of 5 and n is equal to p squared times q, where p and q are prime numbers, which of the following must be a multiple of 25? So here we have a divisibility question. I love divisibility questions, especially when teaching, because divisibility usually shows you how everything is interconnected on the Gmat. So we got this equation here that n is equal to p squared times q. So we can write that as p times q. So we sort of have three terms here that we are multiplying together. And we want to know which of the following has to be a multiple of 25. And we got a combination of p's and q's in our answer choices. So what does that mean? If something's a multiple of 25, if we were to break down 25 into its prime factors, that's 5 times 5, right? So that means which of the following must contain 2 5s, right? So let's think about what do we know? We know n is a multiple of 5, and since n just contains 2 p's and a q, we know that one of these has to be a multiple of 5, either p or q, right? So really all we know to start is either p or q is a multiple of 5, or either p or q contains at least 1 5. And we are looking for what must contain 2 5s. So this is all we know. So, given that this is all we know, let's see what must be true given our answer choices. So does p squared have to be a multiple of 25? No. We know that either p or q is a multiple of 5, and so if q is the multiple of 5, then p might not contain any 5s, and then the same thing is true here. In fact, we know our actual answer choice is going to have to contain a p and a q, right? Because we don't know which one of those contains our 5. So we can eliminate b based on that as well. Statement C says p times q. Well, all we know is that one of these two guys contains 1 5 at least, and so if it only contains 1 5, so even though we have both p and q here, if whichever one is a multiple of 5 only contains 1 5, that's not going to be enough to get us to the 2 5s that we need. And so D, now D here looks like our answer, right? Because D is p times q. So here, regardless whether it's p that contains the 5 or q that contains the 5, we're going to have 2 of those 5s because each one appears twice. And so D is our answer. E, so here we got p cubed times q. And while I agree that if it is p that contains our 5, we'll have 3 5s, which is more than we're looking for. If it's q that contains the 5 and it's only 1 5, that's not going to be enough. We're looking for 2 5s. So D.